So up next is Toni, and he is going to talk about continuously delivering your Puppet code with Jenkins, r10k, and Git. So I'm going to turn it over to Toni Schmidbauer.
So hi everybody. I'm Toni Schmidbauer, and I'm going to talk about continuous delivery of your Puppet code with Jenkins, r10k, and Git, and a few other tools that didn't fit on the presentation title. So it's all about getting your code from the development workstation to the production environment. So who am I? I'm working as a systems administrator at SAT Solutions in Little Austria. SAT Solutions is a subsidiary of Erste Bank, and it's a data center provider and software development company. But I'm a system administrator and not a software developer. So when the Puppet is over and if you've got any questions about the presentation, just drop me an email or contact me on Java. I'm happy to answer all the questions. So let's talk a little bit about the agenda. First of all, I'm going to tell you a little story about configuration management. This is basically the story of how our current setup evolved and the problems we had. Then I'm going to talk a little bit about continuous delivery, what it is, and how we are using it. Then I'm also going to mention a few tools we are using to implement continuous delivery. And what follows is a short demonstration. And last but not least, I'm going to talk about things we still have to improve. So let's begin with a short story about configuration management. At SAT Solutions, we are managing a very diverse environment of systems. We've got Solaris 10 and 11. We're using Spark systems. We got i386 systems. We even got around 150 AX nodes. And we are also using Red Hat Enterprise and CentOS in all the supported versions. So you name it, we have it. We're currently managing around 1,000 nodes in total. And before we were using configuration management, we had very, very strict standards on how to set up these systems and how to configure the systems. But we had one little problem. The count of the team members was equal to the count of standards we had implemented. So obviously, configuration management is and was the solution to all our problems. But there was a slight problem. The solution to all our problems broke our systems. So the next thing you're going to ask yourself, why did this happen? The reason for this is, first of all, it had nothing to do with the configuration management, but it had to do with the thing. It had to do how we were using configuration management. So you were hearing the whole day, Puppet is the way to go, and configuration management is the way to go. This is still valid. You all should use configuration management, but you have to keep a few things in mind. So the problems we had, first of all, our deployments completely sucked. We were using, when we started with configuration management, we were using CF Engine 2, and we had all our CF Engine code base in one large Subversion repository. And when we wanted to do a deployment, we had to manually create a Subversion tag, go to the CF Engine master, check out the tag. So mistakes did happen. For example, we tagged the wrong commit, we checked out the wrong tag. So what we also had was a thing we called deployment in stages. But nevertheless, we still had to cross our fingers and always were very nervous when we had to deploy a new CF Engine code base. So what deployment in stages basically means, we separated all our servers in 4 different stages. And we did the deployment. We shipped the new CF Engine code to the first stage. So all the systems in stage 1 got the new code base. Then we moved on, let's say after an hour, to stage 2 and so on. This was just so that we couldn't break all the systems at the same time. So then our testing also completely sucked, because basically we had none. We had no unit tests for CF Engine, we had no acceptance tests for CF Engine. We had a development environment with 7 to 8 systems, but obviously this wasn't enough, so things did break. then we had no immediate feedback if things are okay or not. So we always had to wait for the systems administrators that are responsible for the particular service to come to us and tell us, guys, I think you broke something on my system. So this is more of a common point that systems that you are currently managing without configuration management are very, very hard to bring under configuration management control, because you have to be very careful when you change the configuration of a running system. So reason for this is every system is a special case. When you have 25 team members and 25 different standards, every system is going to be a special case. So these are the problems. So what's our current solution to all this? It's a thing called continuous delivery. Continuous delivery is a design pattern for getting software from development to release. It comes from the software development side and not from the system administration side. So release in our case is the production environment. And this design pattern is called the deployment pipeline. So what is a deployment pipeline? Basically, you can imagine it as a real pipeline where your code is flowing through, and you separate the pipeline in different stages. And your code has to pass all the different stages. So for example, we start with a commit stage. After the commit, we run automated unit tests. If the unit tests are okay, we move on to the automated acceptance tests. If the acceptance tests are okay, we are tagging a release. And after taking the release, we finally do the deployment. So, and one thing that you also should keep in mind, everything within the deployment pipeline is fully automated in our case. So there's no manual intervention required. So why should you use continuous delivery? First of all, when you automate your deployment, less mistakes will happen, and the same mistake is not going to happen twice. Because as soon as you do a mistake, your deployment pipeline is going to stop, because one of the test cases you've implemented is going to fail. When you do less mistakes, you're less stressed out when you have to do a deployment. When you have less stress doing a deployment, you're going to deploy more often, because why not? And more deployments mean you get a more flexible environment, because in our case, we are currently doing 3 to 4 production deployments a day. So if you would like to read up on continuous delivery, I would really recommend the book with the surprising name, Continuous Delivery. It's written by Jez Humble and David Farley. And this is also the book where I got the idea from. So let's move on to the tools we're currently using to implement our deployment pipeline. So first of all, there's Jenkins. Jenkins is a continuous integration server, which sounds very fancy, but for me it's nothing more or less as a job execution engine. So its main purpose is to execute jobs and monitor the jobs that are running. So a job can be anything that's executable and returns 0 success. So in our case, it's a simple shell script. Jenkins is also very extensible, so there are many plugins available. For example, we are using the Git plugin, the build pipeline plugin, or the monitoring plugin. And the most important thing about Jenkins is that you can link the jobs together to build the pipeline, so you can define dependencies between the jobs. So this is a rather bad screenshot I've taken of one of the pipelines. As you can see here, this is the unit tests that are running. When they are okay, we move on to the acceptance tests. If they are okay, we finally do the deployment. The red box over here indicates that this job failed. And the deployment job, a blue box, indicates that this job did not run. So the acceptance tests failed, and we did not do a deployment. So everything's fine. We're also using the monitoring plugin. This is quite nice. This is a screenshot, a picture I've taken in our office. And we're using the monitoring plugin on a large TV screen, so everybody in the office is aware of one of the jobs is going to fail, because one of the boxes is going to be in dark red. And yeah, you can also see there are currently 2 jobs running, a production Puppet unit test and a feature deployment job. So I'm going to talk about the particular jobs we are using a little bit later. So this is Jenkins. We're also using Git for version control. The most important property of Git we are using is a Git push triggers the deployment pipeline. So as soon as I synchronize my local repository with the remote, I trigger the deployment pipeline. So we're using currently one central Git repository for all our internal modules we're not going to share. We are using Git-to-Lite for access control, so there are different groups of developers with different access rights. We are currently using 3 main branches in the Git repository. We've got the development branch, a testing branch, and the production branch. And this also corresponds to the Puppet environments we are using. We use feature branches for new site local modules. So if a developer would like to develop a new module, he's going to create a feature branch. And all our hero data is in the same Git repository. So let's talk a little bit about the directory layout. So there's a modules directory. This is where r10k, this is a tool I'm going to talk about in a few minutes, downloads all external modules we are using from Puppet Forge, from GitHub, or from any other central Git repository. Then we've got our site directory. These are where the local modules are located. Then we've got the hero directory with all our hero data inside, basically YAML files. There's a Puppet file. This is the configuration file for r10k, where you specify all the modules it should download. And there's a Vagrant file, because we're also using Vagrant to boot the local developer VirtualBox image, where all the tools we're using are pre-installed. So that's our Git repository. So let's move on to the Git workflow. The first thing you're going to be aware of is that I'm very bad at drawing technical diagrams, but nevertheless, I try to explain what's going on here. So on the right-hand side, we've got our 3 Puppet master and our 3 environments. So we've got a development Puppet master with 7 to 8 nodes. We've got a testing Puppet master where we're currently using 40 to 50 nodes. And last but not least, the production Puppet master where all the rest of the nodes are located. Then on the left-hand side, this is our Git repository. So we've got a feature branch for new modules. We're using a development branch, a testing branch, production branch. And in the middle is Jenkins. There's our deployment pipeline. And let's say I'm a Puppet developer and I would like to develop a new module, a new internal module. So the first thing I'm going to do, I clone the central Git repository. I create a feature branch. Within the feature branch, I develop a new module, test it locally, and if I'm fine with it locally, I would like to merge it into the development environment. So as soon as I synchronize, I do a Git push, it triggers a Jenkins job, and it's synchronizing the feature branch into a corresponding Puppet environment on the development Puppet master. So let's say I call the feature new module, and then after the deployment, there's going to be a Puppet environment called new module. There are no unit tests and acceptance tests in between the feature branch deployment and the development Puppet master. Reason for this is sometimes I would like to debug broken modules in the development environment. For example, we are running AIX systems, and I've got currently no possibility to test AIX modules that are running on AIX locally. So I'm just deploying it into the dev environment and test it there and debug it there. So let's say I'm happy with my new module. So the next step is going to be merge it to the dev branch. When I synchronize the dev branch after the merging via git push, this time it triggers the deployment pipeline, so all the unit tests and acceptance tests are going to run, and finally we do the deployment. So, and after development, if the module runs fine in the dev environment, I'm going to merge the module into the testing branch, do a git push, it triggers the pipeline and deploys the module to the test environment. And it's all the same for the production environment. So hopefully this is a little bit clearer now. This is our basic Git workflow. So let's talk a little bit about r10k. R10k is a tool to deploy Puppet environments and modules. What it does, you specify a central Git repository, and for every branch within this repository, it's going to create a corresponding Puppet environment. So we've got our 3 branches: development, testing, production, and we're also getting on the Puppet master 3 different environments: development, testing, and production. What r10k also does, it downloads external modules. So it downloads modules from GitHub or from any other Git repository. One thing that you have to be aware of when you start using r10k, it currently does not handle dependencies. So if you're using modules that have dependencies on other modules, you have to specify all the modules in the Puppet file. So how does a Puppet file look like? This is an example we are using. As you can see, we are using a few modules from Puppet Forge. You can pin the modules to a specific version. And for example, we're also using the Concat module directly from GitHub, because there was a bug in the Concat module where it didn't work on Solaris. So you also got the possibility to use modules directly from GitHub and pin the module to a certain commit hash or branch or tag, whatever you want. So this is quite flexible. So a word on testing. When you're implementing a deployment pipeline, testing becomes really important, because you have to rely on the deployment pipeline that it catches the mistakes you're going to make. So first of all, the unit tests. We are using RSpec Puppet, what else, for unit tests. Then we've got, for the acceptance tests, we're using Puppet Labs Beaker. What it does, it boots, in our case, it boots a Docker container, and we run Puppet apply within the container. This is a thing Beaker does for us, and it also checks after the Puppet apply if our Puppet code did the right thing. So it's really executing Puppet run, because as we've heard before, RSpec Puppet only compiles a catalog and checks the catalog if all the resources you specified are within the catalog, and if all the parameters you're using for your resources do get the right values. So, and once again, you really need to have very good testing when you implement the deployment pipeline. So we test all our internal modules. We also test our Hira data, so there are some basic RSpec tests for all the data we are storing in Hira. We also test our Puppet configuration, so we also deploy our Puppet configuration, our puppet.com file via Jenkins, and there are also some basic tests running. And yeah, all our internal modules are required to have RSpec tests. So if you're developing a new module, you have to have RSpec tests. Otherwise, we won't deploy it. So this is a little example for RSpec Puppet. This is also a module I'm going to use in the demo. It just prints a short message on the console. But this down here is the corresponding RSpec tests. So when the sample module is running with default parameters, it should contain a notifier resource with the name sample message. That's all. Very simple. So let's take a short look on a Beaker example. In this case, we are testing the profile OSS base. OSS base is a profile we are using on every machine. So it contains the Puppet modules we're using on all our systems. And we do a Puppet apply. We include the profile's OSS base. And what Beaker does, it runs Puppet apply. It does apply the profile's OSS base class, and it catches any failure that should happen during the Puppet run. So if there is any failure, any Puppet error during the Puppet run, the acceptance test is going to fail. This is Beaker. So let's do a short demo. Hopefully this works out, because I have a little problem with my screen. So is it readable or yeah? Okay, let's take a shortcut. Let's take a shortcut. Ah, shit. So this is Jenkins running in a Vagrant box. And what I've done for this presentation, I've prepared a Vagrant box where all this toolchain is pre-installed. So there's Git, there's Git-to-Lite, there's a Jenkins running, there's a central Git repository where the sample module is located, so you can try this at home. So as you can see, I've created a few jobs. We are running syntax checks, we are using aspect tests, we run a simple hero test, we tag a release, and finally we do the deployment. So there's also the build pipeline plugin pre-installed. So if I click on the build pipeline, yeah, that's the pipeline. So we start with the syntax checks, we do some hero tests, we run aspect tests, and so on. I can always trigger the deployment pipeline manually. So let's deploy the master environment. And now the build pipeline should be running. Yeah, it started. So it's now executing the syntax checks, the hero test, and so on. One nice thing about Jenkins is that you can also take a look at the console output of the job. So when I click on this little icon, you can see the output. This is very nice for debugging, because when one of the jobs fails, you don't have to execute the job again. You just can take a look at the console output. So what I'm trying now, what you're not going to see, is I'm going to change the module so that the build pipeline breaks. So Vagrant SSH. Just give me a minute. Git puppet. Site sample module. Manifests init. So I'm just changing the resource title to X example message. Do a git commit, do a git push, which should trigger the deployment pipeline once again. Come on. Yeah. And now, because I've changed the resource title and I've got an RSpec test for this, the deployment pipeline should stop at the RSpec tests. Yeah, red icon, the job failed. And you can see the console output of the job. So, yeah. So RSpec expected that the catalog would contain a notify resource sample message, but it didn't contain one because the name was X example message. So much to the demo. If you would like to try this at home, which I would really recommend, if you would like to play around with the deployment pipeline, you need Vagrant, you need an installation of VirtualBox and a Git client. You have to clone the Git repository, cd into the directory, run Vagrant up, connect to the SSH box, and connect to the Vagrant box. And when you open a browser on localhost 8080, it's going to show the Jenkins dashboard. And you can play around with the Vagrant box, change the codes, look into the Git post-receive hook, whatever you want. So let's talk a little bit about the things we still have to improve. We definitely need more tests. We've got plenty of unit tests, but we just started using acceptance tests about a month ago. So we need more test systems. We also need more acceptance tests, because currently we're only doing this basic Puppet apply thing and just check if the Puppet apply executed without an error. But you can also, with Beaker, you've also got the possibility to inspect the system. So for example, if you're managing a daemon, you can also check with Beaker that the daemon is running. If you're creating a user, you can check with Beaker if a login via the user is possible. We would like to use, once again, stages in production, because we've got currently just one Puppet master, so we would like to separate our environment between two Puppet masters. So The deployment is going to be on the first Puppet master, and after an hour, we move to the second Puppet master. And as always, our documentation. So what Puppet Labs should improve? Currently, when you're installing Beaker, it has to be done via Ruby gems, and this is not so easy. It took us, I think, half a day to figure out all the dependencies between the different Ruby gems you're required to use. So if more people should use Beaker, it would be really, really nice if there's an RPM package or a Debian package. Let's do a short summary. Continuous delivery is implemented via deployment pipeline. Within the pipeline, everything is automated. When everything is automated, you need to have tests. Otherwise, you can't rely on the pipeline. And when everything is automated and well-testing, deployment becomes easy. So, and once again, the tools we're using, there's Jenkins to execute jobs. We're using Git as a version control system, Gitolite for access control, r10k to create these Puppet environments from the Git repository and also to download modules. We are using Aspect Puppet for our unit tests, and there's Puppet Labs Beaker for the acceptance tests. So thank you very much for your attention. Questions?
Yeah, me again. Well, I think we've got a quite similar setup, with the difference that we put our modules in their own repositories, but the rest is quite the same. At one point we had a problem with the Puppet file with r10k because with every repository you give him, you can give him an environment where to pull it from development, from staging, from testing. So we think that when you go further with the multi Puppet master instances, you will run into the same problem. So I would recommend to separate the modules into each repository for their own, and every module has their own development, testing, production branch. So you can just link your environment repository on the master to each Puppet file with the correct branch it used to be on. Because with the Git commits, you only showed public repositories without different stages, because you maybe want to develop a module where you got another module which is in production stage as a requirement, for example.
Yeah. Okay. Yeah. To be fair, we started using Jenkins and this deployment pipeline thing about half a year ago, so we are still learning things. Yeah. Because when you're coming from a system administrator side, all this stuff is new. When you're developing software, this is the way to go. But for a system administrator, this is quite new, and a lot of things to learn. Yeah. Yeah.
I use the Gitolite in a similar way, but I don't use, for example, r10k.
R10k, yeah.
R10k to deploy the environments. I use directly triggers and hooks from Gitolite inside. Why this choice to introduce another service to make something that should be done with hooks? It is not a provocatory question, is to understand.
I do understand your question, yeah. The thing is that r10k, the main purpose of r10k are two things. It's creating the Puppet environments for us, and it's also downloading the Puppet modules. So it's just one tool. It could implement this all with a Git hook on the Puppet master, but r10k just works out of the box. It downloads the modules, and there's also the possibility, because we've got a different, we got another department that's now starting to develop Puppet modules, and we do not want to give them access to the central repository. So the idea is they are going to develop their module in a separate repository, and we're just pointing r10k to this module. So it's going to download. They are creating a tag, and it's going to r10k is going to download the module and install it on our Puppet master.
Because in principle, I do the same things. So really, with a simple hook, it's possible to say to Gitulite, push that or update that repository inside the environment, and even if it isn't inside, create the environment and push everything inside. And also for the users, it's the same. So a new user comes, you allows him to create a new repository, which is the environment, the same environment, and then when it push up, if there isn't, it creates the environment and push everything.
Yeah, but how do you download modules from Puppet Forge?
No. Okay, no. That point. No, it is only for development.
Yeah,
so
okay.
for modules that are not already inside. So instead, r10k is able to get from Puppet Forge.
So you do a Puppet module install and.
Okay. No, sorry.
So you're using for Puppet Forge. You're using Puppet module install or.
No. I'm using it for developing Puppet code in. But not uploading it inside the Puppet Forge or wherever from local. Yeah. Locally. So instead, the r10k is able to connect outside.
Yeah, it downloads the modules.
Okay. Now it's clear. Thank you.
Okay.
In which form do you deploy your software? Do you build packages or directly from Git, or how do you do it?
It's a thing r10k does for us, because when you do a Git push, you deploy a new module, you change your code, it triggers the pipeline, and afterwards r10k, it clones the central repository. There's not going to be a package created. It just clones the repository and peeks inside the repository which branches are within the repository. For every branch, it creates a Puppet environment. And I think that it also does, it downloads all the modules that are specified in the Puppet file. So there is no packaging done, it's all done by r10k and by cloning this central repository. And r10k is quite fast because it caches the repository locally.
Maybe just a hint, I too did set up such a deployment chain. Perhaps librarian Puppet is a valid option for you, as it does that point you mentioned earlier. r10k doesn't do any dependency resolution. Librarian Puppet does, even recursively.
Okay. Yeah.
Any other questions? Okay, thanks.
Thank you.